Hello, I'm Ellie. I would like to discuss today a little bit about conda environments in Azure Machine Learning. So before I show you how I do what I wanted to show you today, a quick tour, where do I find these conda environments in Azure Machine Learning and why would I want to control them beyond the obvious? So first of all, I've got already one compute turned on. If I go into the terminal window, I can just go conda and list. It's one of the ways of getting them. And you can see that off the shelf, the Azure Machine Learning comes with pre-populated environments where I usually strongly recommend, until there's a new environment that comes off the shelf, to use the version 3.10 that also includes the Azure Machine Learning SDK, which is the version 2 of the SDK, which is very, very useful. But as you can see, it's not the default. It's always, for some reason, they've decided to go with the version 3.8. Now, it's is and is not directly, and people who work with Python a lot understand this. When you go into a particular notebook, you can see I'm working on the same computer. I've got only one computer in this environment, workspace defined at the moment. You can see the same environments over there, and there's also R here. These environments are the same environments you just saw in beforehand in the terminal window, but also they've been recorded as a kernel for Jupyter Notebook. And I would like to show you how we create our own conda environment. And if you don't specify what version, you will get the latest version. So now I'll get 3.10, and I would like to show you how to get it listed here. So when I run a notebook, I can actually run it within a kernel that I have specified myself. Another place where this is important and useful is when you go and you say, I would like to use a Sparkless compute that is now in GA. You can go and use definition of conda environments to define what will go into this Spark compute. Very important to know how to define a conda environment using a YAML file. You can also do it alternatively as a container, not in the scope here. Where else do I find environments? You can see the word environment appearing as a blade here on the left. Now, this is not necessarily only conda environments. This is also different. You can use these environments also to define most aspects of the compute. So practically this is container definitions. If you, for instance, you go into, I don't know, let's take something with this, sklearn. Okay, here we are. And if I go into the context, you can see here that there's the Docker definition. There's a conda command, and it's actually using here this conda dependencies YAML. So it kind of is using the same approach that I'm showing you here with a little bit more sophistication, and you can create rather than your own and use the environments that come off the shelf from Microsoft. You can create your own either manually or by code. And very importantly, if you come out of the particular workspace that I am and you go to the organization level, and you can, at the moment I've got one workspace, you see here the environments now appear as a shared asset rather than part of the workspace. So you can define environments and share them with other teams that don't have access to your particular workspace, or you can create a register, and within the register, you can create an environment or, and share it with the people that have access to your registry in particular areas and so forth. Uh, the registers and the shared assets are a fascinating concept that I would like to get to and talk to soon. To get this to work right, it isn't enough just to know the technology. One needs also to think about how to get teams to work together, agree on a few common ways of doing stuff, and use tools that help people keep to those agreements. Okay, so let me go to the compute, and I'll create a new compute. I want to show you how I start from scratch. So new compute, AML, demo, 021. Let's stay with the default here. Next. I like to have this always turned on, very wise. To deliberate, I always deliberate whether I put here only 20 minutes or an hour. Having a number here is good. I also ensure that this shuts down. Notice that this hour is UTC, not the. So even if you're in the UK like I am, this actually will shut down for me. Yesterday it shut down for me at 9 o'clock, not at 8, of course, because there's an hour difference between the UK time at the moment and UTC. And I always also enable it on a network. You don't really need for this particular, the purposes of this demo. And I need to change something with regards to the blob storage, which I haven't done, and I'll get to it eventually. I did try with these two. A note about the setup script. If you use the setup script, you can't assume that you're getting all what you're getting usually when you create a computer. You have to set up and install everything, including conda. And I think the startup script, there's something that I need to figure out still of how to automate. You'll see it when I run it, which doesn't get, I couldn't get this to work with the demo that I'm showing now, but it makes sense to just theoretically say, okay, I want to provision, browse, go to my setup here, and just run my sh file. But something does not work well, and I didn't get it on, so I'll show you how I do it manually. But it does make sense to try and use this. And good practice always to have at least a tag which is you've got an environment that is run by many people. It's worthwhile each time you've got the opportunity to add tags, at least tell everybody who to go to ask questions about a particular resource, because it very fast have a tsunami of new resources created within Azure, and it really helps the people who are governing it to ensure that they don't delete something that you really need. Okay, and you can see I didn't set up a startup script and a creation script. By the way, I think there's a bug here. Even when I was playing with the startup script, it did not appear here. Sorry, the creation script, it did not appear. The startup script does get listed. Okay, and create. And we'll wait a while. obviously make this faster in the video. Going to happen. So I've created an SH file, and I'll walk you through it in a second. And the input to this SH file is this conda demo environment YAML file and the requirements file. So let's start with the requirements file. Okay? Requirements file, I've just listed here a few basic Python packages. You can put this in the requirements, by the way. This Azure Machine Learning ones I've did say other places do that. These two are useful for working with blob storages and other data sources. I really, really like working with the .env package. It simplifies a lot, and it doesn't necessitate working with keys, but it's kind of working with keys. So when you don't have really certain secrets, but of course, if you've got really, really sensitive information, it's like passwords and so forth, then secrets is the way forward. Here in .env, I usually use it to just define general information about the environment I'm working in, the workspace name, the resource name, and so forth. It's really important to have the IP kernel added to the installation because one needs it for the last step that I'll show you. Okay. The YAML file itself, as you can see here in the channels, I've also added Hugging Face to show you that you can. I have already automatic, so you can specify in the requirements. Here's the requirements listed over here. Right? So you can specify in the requirements a pip install pointing at the Hugging Face URL, but you do need to be able to do that. You do need to have it as a channel here. If you don't specify Python 3.11 as I've specified here, you will get Python 3.11. I can just delete that and you'll see that that's what happens. So let me just save that and close that. I thought I saved it. Hang on. Save. Yep. So let's close that and let's close that. And let's go to the sh file. So I'm creating a new environment called AML demos. As part of my experimentation, I created it many, many times. So I want just to ensure that I don't have it there when I come to create a new one. If it doesn't exist, then please do create a new environment using my conda environment YAML. To be able for this to work the way it's written, you do need to run it from the setup folder. I'll show you in a second how I do that. Once this is installed, so this line 13 is the key line, yeah? Create an environment, please, using this YAML file, which will use this requirements file. Then I go and I activate it, and I just to be tidy, I write into these three text files what has been installed. I mean, good practice is that in the requirements file and in the YAML file, you actually specify versions for each and one of the packages that you refer to, so that you have a very stable and fixed environment, and which allows you to replicate your jobs when you try to a year later to double check them in production settings. That is the only way to go forward. Create an environment where everything is clearly specified and recorded. Here, when I'm just demoing stuff, I would prefer to, and maybe when I'm doing R&D, is to use the latest. Having been around for quite a while, I've learned that the latest is the best option, mainly when you want to avoid using, I mean, you want to include bug fixes and security fixes as fast as possible and not wait until you have the courage to do that. Now, line 26 is the line that does the magic. To have line 26 working, you do need to have the conda environment activated. And then when you run this IP kernel job, this is where you will get the conda environment also listed as a notebook environment, as I showed you beforehand. Okay, let's see if my compute is already done. Oh yeah, we've got now two computes running. If I go and say, please, no, sorry, I wanted to show you how to do it. So I go to setup, that's the folder I want to run from, and I say open terminal. Notice I did not say which compute to use. Once I've opened the terminal, I can choose. I mean, by default, it went to the compute I wanted, but I could have said, okay, you know what? No, I want to run it on my other compute. Now, let's stay with the AML demo 02. That's the one I wanted. So all I need to do now is I can run in a few ways, as Unix allows in several ways. Let me just run it this way. Source, which didn't want setup. Set up. I want to run my sh file. Now, there is one thing that it's going, if you do also all the updates, it will, if you do sudo update get and all that stuff, it will ask you a few questions that there's one question about one particular service that I couldn't automate, and although I researched it, but this should run end to end. It will take some time. So notice I'm starting here at 11:51, and of course I will speed up the once. Okay, I kind of got bored waiting for the process to run. I left it, did some other stuff, and came back, and obviously the compute timed out. So what I should have done, or I can do when I run long jobs, and I don't do a lot, is use no hap with a big P, sorry, no hap, and then I can do source setup and run that, and even if the terminal window times out, the job still runs. So you can actually also, if you really want to be, can add an ampersand at the end, and the log will be recorded in a text file. You can actually control that. If you look into the nohap command, you can refine exactly where the log files are recorded. However, even when the terminal window is aborted, the job itself still runs until completion. You can see here, if I just run a refresh quickly, these files were created for running the setup demo. So if I just check, for instance, this one, and I look at the time, so it was written at 11:06. If you remember, I kicked off the job at about 10:51. So we've got here about quarter of an hour running, and I didn't choose the fastest compute available. But it does take time and it does need patience. But once it's done, and all you need to do is do the conda activate. So if I just come back here to the terminal window, and we go conda and list, should have here also an environment called AML demos. And if I activate AML demos. And you can see here now that I'm in that environment. And if I do Python version, yeah, hyphen 3.11.5. And you can see if I go in here, you can see exactly which sorry, this is the version, of course. This is the pip PyPy packages that were installed, and these are the versions for them. Now, because I'll just remind you, the last line here in line 26 was running this IP kernel CLI, taking AML demos and creating a Python kernel called AML demos. So if we just go into this notebook here, you notice I'm on the second compute. If I list here now, you'll see that I've got AML demos, and I will add here. I see it. I didn't get the latest. I've got the version also that runs and checks what the version is within Python, but I can guarantee that it's 3.11. Okay, thank you very much for listening.